Hello students, I am going to discuss about a very common concept that has problems for all ICSE students who are studying in class 10th. Now since the board examination is approaching, so I thought of giving you some information regarding a particular topic called force experienced by a current carrying conductor in a magnetic field, which is a topic from the chapter of electromagnetism. Now, when we talk about this particular topic, force experienced by a conductor in a magnetic field, first of all, we have to understand that any current carrying conductor, suppose this is a conductor and this conductor is carrying current. Now, if this conductor is carrying current, obviously there will be some magnetic field around it, because we already know that current carrying conductor has magnetic field around it. But what happens when we place this particular conductor in an external magnetic field? Now that magnetic field is due to some source, but we are not sure about the source. We are not really interested about the kind of source we are using, but there is some external magnetic field in which I have kept this conductor, say wire, which is carrying current in a magnetic field. Now the force experienced by this conductor, as you can see in the board, is given by, it depends upon length of this wire, of course, and current flowing through this wire. The magnetic field, this particular magnetic field is the external magnetic field in which we have kept this particular wire. And in that case, the force becomes ILB for class 10 standard students. We will say the force experienced by this conductor will be F equal to ILB. Now the common mistake that student most often do, what will happen if we increase the current? Of course, if we increase the current in this conductor, the magnetic field will increase. If we increase the length of the conductor, of course the force will increase. I am saying that if the length of the conductor is increased, then of course force will increase, and similarly if I increase the current of this conductor, then of course force will also increase, and if we increase the magnetic field, then of course force will increase. Now sometimes what students think that if the current flowing through this wire is increased, the magnetic field around that particular wire is increased, and that is why it is feeling the force. No, that is the wrong concept, because this wire actually cannot experience any force due to its own magnetic field. ये वायर अपने मैग्नेटिक फील्ड के कारण जो फोर्स है उसको एक्सपीरियंस कर ही नहीं सकता. फॉर एग्जाम्पल, वी कैनॉट एक्सपीरियंस ग्रेविटेशनल फील्ड ड्यू टू आवर ओन मास. इवन इफ यू गो टू स्पेस, अगर हम स्पेस पे भी गए, हम अपने मास के कारण मैग्नेटिक ग्रेविटेशनल फील्ड एक्सपीरियंस नहीं कर पाएंगे. सिमिलरली this wire that you can see on the board is carrying current. It will not be able to experience any force due to its own magnetic field. It can only experience force due to the external magnetic field, which you can see. I have drawn a boundary of the magnetic field, in which I have shown the magnetic field as crossed magnetic field, which means the direction is into the board or into the paper, and in that case the force is ILB. So here when we are talking about the magnetic field B, remember that magnetic field is the external magnetic field, and if you increase the current, the magnetic field of the around the wire increases. Well, it works in such a manner using Newton's third law. If I increase current in this wire, of course there will be increase in the magnetic field around this wire, but at the same time there is a external source of magnetic field which will exert a force. So this particular wire may exert a force on any other conductor placed in the magnetic field, but in this case we are only thinking this conductor as a test wire which is carrying current. यानी कि हम इससे ये पता करना चाहते हैं कि ये फोर्स एक्सपीरियंस करेगा या नहीं करेगा अगर हम इसको मैग्नेटिक फील्ड में, एक्सटर्नल मैग्नेटिक फील्ड में प्लेस करें. तो ये खुद का जो करंट है उसके कारण कोई मैग्नेटिक फील्ड एक्सपीरियंस नहीं कर सकता, ये सिर्फ एक्सटर्नल मैग्नेटिक फील्ड को ही एक्सपीरियंस कर सकता है. तो ज्यादातर स्टूडेंट्स के कॉन्सेप्ट में ये गड़बड़ी होती है कि वो समझते हैं कि हम करंट यहाँ पर ज्यादा पास करेंगे तो ऑफ कोर्स फोर्स ज्यादा एक्सपीरियंस करेगा ये वायर. बट रीजन क्या है, ये खुद का मैग्नेटिक फील्ड एक्सपीरियंस नहीं कर पाता है, बट हम जब करंट यहाँ पर इंक्रीज करेंगे ऑब्वियसली इसका मैग्नेटिक फील्ड सराउंडिंग में इंक्रीज करेगा, बट उसको एक्सपीरियंस नहीं कर पाता है. दैट मैग्नेटिक फील्ड विल हैव एन इफेक्ट ऑन द एक्सटर्नल मैग्नेटिक फील्ड. जैसे मैंने एक वॉल पे फोर्स एक्सर्ट किया, वो वॉल भी मेरे ऊपर में उतना ही फोर्स एक्सर्ट करेगा एंड द वॉल इज स्टेशनरी ऑब्वियसली, तो मैं जितना फोर्स दूंगा वॉल भी उतना ही फोर्स मेरे ऊपर में एक्सर्ट करेगा। तो जिस कारण से ये वायर जो है, जो करंट कैरी कर रहा है, वो सिर्फ एक्सटर्नल मैग्नेटिक फील्ड को ही एक्सपीरियंस कर सकता है। उसके कारण जो फोर्स होगा, दैट फोर्स विल बी एक्सपीरियंस बाय दिस वायर एंड नॉट ड्यू टू इट्स ओन मैग्नेटिक फील्ड। सो कोई भी कंडक्टर, current carrying conductor, it of course creates a magnetic field around it, but it is not able to experience the force due to its own current. It is only the force experienced due to the external magnetic field. Thank you.